The purpose of this video is to explain the relationship between template point names, template component names, feature definitions, breakline geometry, and component mesh geometry. This foundational topic is often overlooked or underexplained. However, it is very important for modelers to understand. Mastery of this information is critical for modeling and successful delivery of final surface geometry. We will be covering a basic overview of modeling concepts. We'll discuss the relationship between feature definitions, breaklines, and component mesh geometry. And finally, we'll cover how to leverage this knowledge to deliver final surfaces. Let us begin by covering some terminology and discussing the modeling process at a conceptual level. As you can see here in the diagram, we have an alignment, which represents both horizontal and vertical geometry. We also have points, and these points are connected to create enclosed polygons that we refer to as components. We combine points and components together to represent the cross-section of our road, and we store this information as a template. We manage individual components and templates in a template library. The process of modeling involves creating these templates and directing OpenRoads to place them along the alignment at a specified template drop interval. As you can see here, we have several templates placed along the alignment. As OpenRoads processes the corridor, the software creates new 3D lines that automatically connect the points with the same point name in each template drop. We call these new elements breaklines. OpenRoads also joins the enclosed components with the same name and creates new 3D mesh volumes. We simply call these meshes or civil mesh elements. Modeling is the process of creating templates that represent your design intent and placing them along the alignment. The software takes care of connecting the points and components to create breaklines and mesh elements. OpenRoads has several tools and techniques available to make the templates adjust dynamically along the alignment, so the final outputs match our design intent as it changes. Once complete, the breaklines can be used to create terrains or surfaces in other software. Contractors will often use these breaklines to create surfaces for estimation and quantity validation. They are also sometimes used to create machine control files that allow robotic earth-moving equipment to autonomously grade the design surface. This is called Automated Machine Guidance, or AMG. The component meshes are 3D elements that allow for very precise volumetric quantities reporting and are preferred over the traditional average end area calculations from legacy applications and workflows. Now let's jump into OpenRoads and look at this more closely. So here we are in OpenRoads, and as you can see, we have a 3D corridor. I'm going to go ahead and zoom in here just to the end of the corridor so we can do a comparison. We're looking at the right side of the template, and let's go ahead and open up the template library. The template library has a number of items in it, but we are placing this particular template. If I double click on it, it opens it up over here. You can see there are a bunch of point names, there are points, there are components, and I am going to turn off the point names temporarily so we can see this a little closer. And if you look at the right side over here, you'll see that it's vertically exaggerated. I can flatten it out a little bit. And this geometry is being placed along the corridor at a specified interval. I believe this is 25 feet. So every 25 feet you'll see a lateral line here, and that's where the template has been placed. And in between those template drops, the software is creating breaklines and component meshes. So let's take a little bit closer look here at this curb and gutter. This curb and gutter is an enclosed polygon. It represents curb and gutter, and it has a feature definition. When I double click on it and go to properties, I see that it has a feature definition. And this feature definition stands for, it's TC for template component, and it's curb and gutter type B. So you'll notice that this exact nomenclature gets applied to the three-dimensional extrusion or component mesh in the model. So if I close this and close the library, and I look at this same component, which is right here, you'll see that this new piece of geometry utilizes that defined feature definition and applies it right here to this element. So every single 2D component in the template is extruded to create a component mesh in 3D space. And the feature definition is carried over from the dialog and applied to the new geometry. So that's a component mesh. But now let's look at the break lines. And while we're here, you'll notice that under the Explorer, under Open Road Standards, that we've got a number of items here that we can toggle on and off. And one of those is meshes. I can choose to turn all of the meshes off. And here now all you see is the alignment, the horizontal and vertical representation of our alignment. I can choose a very specific mesh. In fact, I could just turn on everything that has the curb and gutter feature definition, and you'll see it turns on just those elements, just those mesh elements. But we've talked about those. So now let's look at the break lines. Remember, the points that define the components are also connected. They're connected with three-dimensional break lines. And if you go to the linears, you'll see under template linear, I can expand this, and we have some different subcategories. If I go to roadway, you'll see that I have a feature definition that starts with TL, and TL stands for template line or template linear. And you'll see there are a number of them in here, and I can individually choose one of these, or I can choose all of these, and it will give me all of the lines that are basically connecting up points of the same name inside of our template library. And these break lines take on the feature definition that's applied to the point in the template. So that's how we create 3D break lines, and that's how we create component meshes. Next, we're going to talk about how to use these break lines, or rather how to select these break lines to create terrain elements. As we mentioned previously, it's not uncommon to need to deliver a surface representing your top, bottom, or some intermediate layer of your design. There are a number of ways that you can go about doing this, but generally you're creating a surface from your break lines. Now, if you just had your break lines like you have them here, and we were left to try to manually select which ones represented a top or a bottom, it would be very difficult. We could be a little smarter about it by opening up our template library, for example, and finding our specific template. And we could go in here and we could turn off the point names. We could go to active template. We could go to point feature definitions. And we could meticulously work through and figure out by selecting the various points which of these feature definitions fall, let's say for example, in the top. If we wanted to create a top surface, we could manually figure out, so these happen to say top in them, so there's template linear or template line curb face top, so we know that's one of the feature definitions we would need to select. And we could go through and work our way through the template and capture all of the feature definitions that exist in a top or a bottom. That would be very tedious. Then you'd have to go over here and you'd have to find just those particular ones and toggle them on or off. And then when you're done, then you could select all of the break lines that are left on, and then you could go to terrain and say create from elements. But again, that's very tedious. And what if you have 20 or 30 different templates and you've got different pieces of modeling? So there is a functionality that exists in the software that allows you to reference in all of the different modeling components and have it select graphically those features that are relevant to a given surface. And we have taken the time to build these filters out for you so that you don't have to do that work. So the way this works is that you'll go to Terrain, and you'll see here that I actually have all of the break lines on in this particular file. So I could make a brand new file and reference this in, but I'm just going to go ahead and create this terrain inside this file of my top surface using this methodology. So I'm going to go to Terrain. I'm going to create a terrain from Graphical Filter, and you'll see it opens up this dialog, and it's asking me to choose a filter group. So I'm going to click on this dialog here, the little ellipses, and I'm going to tell it that I want to create a proposed finish grade surface. And the triangulation method, I'm going to go ahead and just choose remove slivers. We'll go ahead and give this terrain a feature definition. Now it's going to create a new terrain element from just the features that are relevant. So I'm going to go Terrain. We're going to make this is a proposed surface, and we'll call this Proposed Design Triangle so we can actually see it. And so now I'm just going to data button through the heads-up display here. It took a second, but now that it's done processing, you'll see that we have a top surface. And if I zoom in to the end, you'll see that it has ignored all of the features that are not part of the top. You can see the break lines underneath. So that's how you can create a terrain with a graphical filter.